Hey guys, welcome back to the continuation of moles and stoichiometric calculations. We have just done the calculation related to mass and moles in a previous question. I'm just taking you back to the previous video. Okay, so in this question, I have just told you that you are going to calculate the moles first and then you are going to calculate the mass. So this is the basic point that whenever examiner is asking you to do any type of calculation, you need to come to the moles first and then you go to the next calculation from that mole. I am right now on a next question. You can check this thing. Examiner is asking. I'm just spotlighting question number 7. And okay, I am highlighting this as well. Okay, now you can check this thing. What is the mass of calcium carbonate needed to react with 200 grams of HCl? If a student does not know this thing, that what is the balanced chemical equation between HCl and CaCO3, then definitely it's a problem. So right now, students should know this thing that 2 moles of HCl are reacting with 1 mole of CaCO3 to give 1 mole of CaCl2, 1 mole of H2O, and 1 mole of CO2. So now what is that 1 and 2? Remember this thing that in a balanced chemical equation, the numbers which are written before reactants or products are considered as moles. So this number is considered as mole. Here it is 1, so it is 1, it is 1, it is 1, and it is 1. When there is nothing written, it is considered as 1. Then when we have written the balanced chemical equation, we have seen this thing that we are now going to calculate the moles of HCl. How we are going to calculate the moles of HCl? I have just told you on the previous page that what about the moles formula? Moles is equal to, basically, moles is equal to mass over mr slash ar. I am writing this formula again so that if anyone is forgetting the concept, should know this thing very well. Okay, so moles is equal to mass over mr slash ar. So here this is the mr for HCl, which is 36.5. So I am just doing 200 divided by 36.5, which is giving you 5.479. Okay, you may check my calculations as well. This is never necessary that a teacher is calculating. Might be there can be a human error. So please, all of you are requested to check the calculations as well. So 2 moles of HCl, according to the balanced chemical equation, 2 moles of HCl are reacting with 1 mole of CaCO3. Then 5.479 moles of HCl, which you have calculated, are going to react with X moles of CaCO3. X answer is 2.7395 moles. So this is the value of moles of CaCO3 which you have calculated. Okay. So mass, now you look at the question again. What is the mass of CaCO3? So first of all, from the moles of HCl, we have calculated the moles of CaCO3. Then from those moles, we are now going to calculate the mass. Let's see. Mass for 2.7395 moles of CaCO3. 1 mole of CaCO3 is equal to 100. How it is 100? If you are looking into the periodic table, calcium is 40, carbon is 12, oxygen's mass is, I must say, oxygen's AR value, that is the relative atomic mass of oxygen, is 16. We are going to multiply it by 3. Why we are going to multiply it by 3? Because we know this thing that oxygen is for 3 times. That's why we are going to multiply it by 3. Then we can check this thing that when we are going to add this whole thing, it is going to give us 100. So 1 mole of CaCO3 is going to give us 100. 2.7395 will give you X. So as a result, this will give you the value, that is the 273.95. I'm repeating the whole concept again. So first of all, examiner is asking mass from mass. From the mass of HCl, he is asking the mass for CaCO3. Then you are going to calculate the moles of HCl, and then from those moles, a balanced chemical equation will tell you the moles of CaCO3. Those moles will give you the mass of CaCO3. Again, the repetition of the same point. As far as you are not calculating the moles, answer will be considered as wrong. Another question is there, what will be the mass of ethane? Ethane required to produce 300 grams of CO2. Remember this thing, those students who have not studied organic chemistry yet, please don't worry about such type of the formulas in your school test or school exams or etc. will be provided, but they will not be given in the Cambridge exam. Why it is so? Because over there, as it is the exam of the complete syllabus, so it is considered that organic chemistry simple formulas must be in the mind of the student. So ethane C2H6 is a hydrocarbon. Now the word hydrocarbon is introduced to you. Although I have recorded the lectures of organic chemistry already. Those students who have practiced organic chemistry from those lectures already know this thing, that hydrocarbons are those compounds which are combination of carbon and hydrogen. Hydrocarbon is a combination of carbon and hydrogen, as this is two carbons and six hydrogen. Whatsoever is the combination, CH4 methane is another type of a combination, but it is falling under the category of hydrocarbons. We can see this thing that when a hydrocarbon undergoes combustion, combustion is a scientific term used for burning process, different products produce. In case of complete combustion, CO2 and H2O are the products, whereas in case of incomplete combustion, carbon monoxide and water are the products. So remember this thing, that this we have done over there in case of organic chemistry. This will be my advice to all of you, to go through the combustion process, combustion of organic compounds. It will be quite helpful to you. Now look at here right now, as question is about CO2, so it is complete combustion. So this is the whole background I have just developed for this question. Right now I'm on the next page, ethane and alkane. It has formula C2H6. It is just the thing which I have told you on the previous page, that it has formula C2H6. There is no need to memorize this thing that it is an alkane, as far as you are not going to study organic chemistry, or as far as you have not studied organic chemistry in your school. Okay, if you have studied organic chemistry, if you are going to appear for 2026 exam, then definitely you should know organic chemistry now, and you should be able to you should be about to finish your syllabus. You should be about to finish your syllabus. That's why organic chemistry, if you have done, good, well, good enough. But if you have not done, you are left with shorter interval of time to complete this. Because I know this thing, that many of the schools, at least in Pakistan, I can tell this thing, that many of the schools are conducting 100% syllabus for December test. So I believe that this is the strategy for many other places as well. Many places are having exams in different type of the series, and most of the schools are taking complete syllabus exam in December. So you people are left with shorter interval of time. Okay, so an alkane, ethane is an alkane, so it is C2H6, already discussed in organic chemistry. This I have written over there, so that any student, if have any confusion or a query, or wants to have further details, can go to that YouTube video. Okay, guys, look at here right now. I am writing an equation. It is C2H6, okay, and then 3.5O2, okay. So it is you can say 2CO2 and 3H2O. We have just written according to the balanced chemical equation, okay. And then it is not a cross. Please, we are going to multiply it by 2, okay. So instead of writing 3.5 in the balancing of the equation, look at here right now, in the balancing of the equation number 1, we are just writing 3.5 with oxygen to make it balanced. But to avoid that point, some of the students don't like that point, but let me inform you very clearly, point balancing is perfectly okay in your syllabus, in your demand of the syllabus. Okay, so right now, we can say this thing, that we can convert 3.5 into a whole figure just by multiplying it by 2. We can convert 3.5 into like a 7. If we are going to multiply it by 2, it will become 7, and as a result, it will become 2, and it will become 4, and it will become 6, and etc. Okay, so this is the way to convert the things into their whole figures. Okay, you can check this thing. Here I am just writing, instead of, okay, I have just calculated some of the values that I am erasing right now. Okay, so that no one get any confusion. Okay, look at here, guys. Okay, so first of all, I am just 4 moles. Look at here right now, 44 into 4. If what question is saying, I'm repeating that, what will be the mass of ethane required to produce 300 grams of carbon dioxide? It means that our concern is with this and this. Our concern is not with oxygen and not with water as well. It is not water, basically. It is I mean to say, it is water in the form of steam, you may say like this. Okay, because it is a combustion process, so burning is having a high temperature. That's why it is steam. So we are not concerned with steam, and we are not concerned with oxygen as well. Why it is so? Because question is revolving around ethane and carbon dioxide. That's why I have just highlighted those. Now look at here right now. We are just saying this thing, that what will be the mass of ethane produced from 300 grams of carbon dioxide. We can check this thing, that 44 times 4 carbon dioxide is produced from 30 times 2, 3286. How it is 30? Like C2 is 24, 12 plus 12 plus 6 is 30 times 2 according to the balanced chemical equation. 44 is the mass of carbon dioxide. It is for 4 times, that's why 4. Is carbon dioxide is obtained from this, and 300 of carbon dioxide is obtained from this. Okay, we can say it right now, but remember this thing that we are going to calculate the, we have to calculate the moles. Okay, we can say this thing that 4 moles are giving you what? 4 moles are giving you 2 moles of this, and 6.818 moles of carbon dioxide will be obtained from this. We have to calculate the moles of 300 grams of carbon dioxide. 300 divided by 44 is giving you what? 6.818. You may say like 300 grams of carbon dioxide. 44 grams of carbon dioxide is equal to 1 mole. 300 grams of carbon dioxide will be equal to 6.818. You can simply do this thing that 300 divided by 44 is giving you 6.818. So it is like these many moles. Now from this mole you can calculate the mass of C2H6 as well. You can say this thing that 1 mole of C2H6 is equal to 30. 30 is the mass of 1 mole of C2H6. Then you can say this thing that 3.409 is equal to 102.2. So remember this thing that you have to calculate the moles first, and from those moles you have to calculate the mass. For example, if examiner is giving you mass, you can come towards mole directly. But if examiner is giving you mass and moles like a interconversion type of a thingy, remember, please calculate the moles first. I am telling you, and I will keep on telling you, inshallah, that moles formula is equal to mass divided by mr slash ar. So this is really very important. Right now I am on the next concept, and that is moles in case of gases. Okay, we can say this thing that in case of gases, basically 1 mole of every gas occupies a specific volume. And what is that specific volume? That specific volume is 24 decimeter cube. 24 decimeter cube is equal to 24,000 centimeter cube. I am working on the conversions on the coming pages. So we can say this thing that volume of 1 mole of every gas is 24 decimeter cube. Now remember this thing that what is volume? Volume is an area occupied by an object. So we can say this thing that 1 mole of every gas occupies volume of 24 decimeter cube. So it is like that. 1 decimeter cube is equal to 1000 centimeter cube basically. So volume of every gas in centimeter cube is 24,000 centimeter cube. So this is really very important. We can move to the next one, and in case of gases, ratio of moles is equal to ratio of volume. Consider the following equation: and 2 plus 3 H2, 2 NH3. So it is 1 here, 3 here, and 2 here. 1 moles mean 24, 3 moles mean 72, 2 moles mean 48. And we can say this thing as well that 24 decimeter cube mass of nitrogen is 28 as well. Why it is so? One nitrogen is 14 and the other is 14. So it will become 28. One hydrogen is 1. So 3 into 2 is 6. So it will become 6. One ammonia is 17 and the two ammonias will become 34. How one ammonia is 17? It is nitrogen 14 plus 3 hydrogen 111. So it will become 17 times 2 is 34. So its volume in centimeter cube will become 24,000 centimeter cube, 72,000 centimeter cube, whereas 48,000 centimeter cube. This is the way to convert the one thing into another. So from the question, from the balanced chemical equation, ratio of moles is equal to ratio of volume. If they have a ratio of moles of 1 is to 3, their volume ratio will be 1 is to 3 as well. If they have a ratio of 3 is to 2, their volume ratio will be 3 is to 2 as well. So look at here right now: 3 is to 2, 3 is to 2, 3 is to 2. So this is how, but mass ratio is not like in the same pattern. So please look it into the fact that volume and mole ratio is like 1 is to 1 in case of gases. This is an important point to be kept in the mind very clearly. Okay, I am right now giving you another example for the formation of steam from hydrogen and oxygen gases. When we are writing a balanced chemical equation, it is like a 2H2 plus O2 giving you 2H2O. Okay, we can say this thing that 2 moles of hydrogen is reacting with 1 mole of oxygen to give you 2 moles of steam. Okay, so what is the mass of 2 moles of hydrogen? 4. 1 mole of oxygen 32 and 2 moles of steam is 36. Okay, so 48 is the mass, 48 decimeter cube is the volume for hydrogen. Why it is 48? Because it is 2 moles. And what about the oxygen? As it is 1 mole, so it will become 24 decimeter cube. In case of steam, as it is 2 moles, so we can say this thing that it is 24 decimeter cube as well. So if we are going to convert this decimeter cube into centimeter cube, it will become 48 decimeter cube is turning itself into 48,000 centimeter cube. Similarly, 24,000 centimeter cube and 48,000 centimeter cube. We can say this thing that hydrogen and steam are in 1:1 ratio, whereas hydrogen is double than that of oxygen. So there are some informations you people can get from these two examples. Here are certain questions which I have solved for the explanation, for the practice of the moles and gases and volume calculations, etc. Inshallah, that I am going to discuss with all of you in the next video. Take care of yourself.